It's noon, and you've arrived at BAS 101, and I am Therese Sullivan from Tridium, and I'm here with the man himself, Scott Cochran.
Cochran Supply.
Cochran Supply, right. A little background on me. I live in Silicon Valley, so we saw a parade of Silicon Valley people in this room, and I, too, have worked in buildings, but out of the Sunnyvale, Santa Clara area for many years. I've worked at numerous startups, one for lighting that was called Enlighted, purchased by Siemens. I did contract work with OSI Soft, and Comfy, and another company that went through its funding and disappeared, Sirius Energy. Which dealt a lot with the envelope and the special glass that never actually got produced. And so we're going to get back to talking about 101. We're going to get back to talking about BAS 101. And so I was starting us off with this picture, which is kind of a ideal situation of a control of possibly the facility manager, but he has a complete HVAC system, metering system set up, and he's got it all beautifully visualized on his screen. In Niagara, and by the way, this isn't a mock-up. This is not a fake screenshot. Those are real screenshots on a real computer. And when I think about the BAS, this is, in my simple terms, in my simple way, I understand how the airflow is running through this thing. I understand what the water flow is, what's happening with the data. And I actually have an allegory to this slide where it's the specifying engineer or the commissioning authority checking out things before construction, before this beautiful picture happens. And so it's more like thought bubbles. I understand how I want the air to flow. I understand how I want the water to flow. How do I want the data to flow? Basically, we think in terms of the data model. And so that's just kind of like a scene setter there. I think I bored us with one more picture like this, but you've already seen it. Scott, with my scene setter, I should let you introduce yourself too.
Hi, everybody. I'm Scott Cochran with Cochran Supply. I'm the president. I've been in the industry for over 25 years. I'm second generation, so I was kind of born into it. Today what we're going to try to do is give you guys some good info on essentially on the architecture and data of BAS systems and how they plug together and how the data moves and essentially kind of give you the basics along those lines. Correct?
Correct.
And this is an open dialogue type of session here. So don't wait till the end to ask questions. If you have a question on any of these topics, let's handle it while the slide's up so we can dive into it. And hopefully I'll get a couple good nuggets out of this. So.
Right. Again, so this is what we're going to try to cover very quickly. Mostly these are pictures, by the way, but what's the challenge that we're trying to solve with a building automation system? What do people look at today when they see that challenge? What's the simple situation? And then where are we going next in terms of a 3-tier architecture? The cyber challenges. Once you've moved your BAS system into a cloud, off premises at all, or connected at all, you have to really think about. And as Scott has famously said, it was really Tridium at one point in time that introduced, or at least popularized, having a open protocol BAS with HTML, and at that point in time, we had cybersecurity to think about. So that's going to be a big part that we would like to cover, and especially hear from you, how you're experiencing that. And then we kind of want to get a little bit into the green field of what we're looking at next. In terms of, again, this thought about how do you want to architect a BAS system for growth, Nobody wants to be the company that in 2008 introduced pneumatics. You want to think about what's the next best step. So get an idea of what's coming next. Dive into this beautiful picture.
So the HVAC industry has gone through an evolution over the last 20 years. Obviously, a lot of you, anybody do pneumatics here? No? I guess I'm the only one. No, we got somebody else. So pneumatics was all pressure-driven control. It was all electromechanical. It relied on a single compressor or a couple of them, and it would feed air to these control devices. Little bimetal elements would actually physically warp by temperature, restricting airflow, and that's how we control temperature. It was so complicated, right? So then along came the computers, and the computers created a huge advantage in controlling temperature in these buildings. And so every manufacturer of control systems jumped on it right away. And what they did was they each kind of came up with their own computer, if you may, to run their systems. And what we started with as we digitized the control industry is we ended up with what we now call a bunch of different legacy systems. And these systems essentially were BAS systems that were developed by a single manufacturer. Software, hardware, network, the whole thing came from one company, okay? And that network ended in a desktop computer in a boiler room somewhere, typically, right? And as the building grew or as they needed more systems, well, here we go, more desktops. And I'm sure many of you today can tell me of a job site where they still have a bunch of these desktops. And there's a lot of reasons why this got changed, right? And I'm sure a lot of it is just common sense. I don't really need to tell you all the inefficiencies of having, 7 or 8 different computers with 7 or 8 different pieces of software, right? IT departments, that's their worst nightmare. If they see it, they just you can't have that. We're not updating at XP anymore. So this is, this is typically, guys, this is like 70% I'd say, maybe 65% of the buildings you walk into will have these legacy systems still running today. So is that fair assessment?
Exactly. You want my next nightmare picture? Because we get better, but we're still in a little bit of a nightmare. You get, okay, it's my turn. You get a tangle of standards. It's much better if you walk into this situation where somebody understands enough about their data to be pulling things in. And maybe you've got a server room. Again, this is highly rendered, stylized, pretend here, but it's kind of like this. You've got BACnet data coming in, and then you actually have your meters. A lot of your meters are on Modbus. You have LawnWorks because you have some industrial stuff that you have. This OSDP standard at the end is access control, really coming on strong in access control. Niagara, many buildings have some Niagara, and that is another open standards. I kind of called all of these, committees getting together and creating these open standards, but still you end up with a lot of them. Dolly for lighting. You can also actually bring your lighting in through BACnet, which I learned yesterday right here. And OPC, very popular in computer centers, as well as SNMP, very popular in computer centers, and MQTT, of course, coming on real strong for all sorts of different applications in computer data centers as well as agricultural farm fields. So it's still, you have the problem of bringing in, one more picture, what you want to do with this, and this is where the nightmare's over, and you want to have a nice, and this is my ideal again, you want to have a nice tidy controls panel where you can look at your buildings or your portfolio of buildings or your campus in a holistic way, zone by zone. Those are all, again, a little bit imaginary rendered labels I put on those things. But you have a central console where you can have graphics and visualization of everything that's going on, just like the guy in the front picture, and the ability to define logic and sequence of operations through that same console.
Can I add to some
go
of this?
ahead.
Can you go back one slide real quick? So the open standards. So the computers on the desk were all being fed by essentially a wire that was connected to the controllers, and on that wire was what we call a proprietary standard. Proprietary means that it was written by a single company or entity, and they control it. Okay. Well, clearly HVAC is not a single entity business. We have way too many different pieces of equipment, and building automation, of course, we stretch across lighting, energy management, even security, life safety. So what happened in the industry was there was a need for what we call open protocols. And what an open protocol was again, it was for that language that would connect all the controllers, bring it back to the computer. But now what these open protocols gave us was we'd have multiple manufacturers using the same protocol. And when they started doing that, that allowed us to mix their devices on the same networks. And that's where that word open came from, right? Open protocol, because it makes it open for the people installing or the people using it to use multiple products from different manufacturers on the same wire and bring them back to the same computer. This was a revolution for the industry, and many standards got developed. Of course, in HVAC, the number one standard we all know is what?
BACnet.
BACnet. I mean, that's who's in charge of this conference. So and they're working really hard on it, and they continue to invest, and there's many people working on it. But we're not the only people working with networks, right? You got all sorts of different industrials. You got different, you got lighting companies. You have security companies, and they all went through the same evolution with these protocols. Okay. And so what we ended up with, funny enough, is we ended up with open protocols from all sorts of, other industries as well. And that's where we get like Modbus and the OSOP, right? And then, are you guys ready for this? Then we realized that our computers got to talk to each other. Okay. And what we were doing before was some heavy lifting to get these computers to talk to each other. So we looked out at the IT industry and we said, I wonder what standards they have that we could adopt so that we can start getting these computers to talk to each other. And that's why we started using SNMP, MQTT. So we started to, this is where we really started to open things up, because not only did it allow our computers to talk to each other, but now we could talk to computer equipment with our systems, which just broadened the horizon for what BAS can do. Many of you know, one of the fastest growing segments in the BAS market today is the data center segment. And a lot of that has to do with the fact that our industry, we can talk to all the protocols that are in the data center and bring it back to the users in a format that they're able to do. So,
How
but
about
anyways.
we do questions again. That you did so well, but I liked how Phil kept opening it up to questions. Any questions on any of that?
The protocols are really important because they're one of the biggest factors in the project success is how that protocol and how it's utilized. So.
What's an example of a computer talking advantage?
Yeah, it's a great question. So like you see a lot of people selling analytics today, right? So analytics is going to want to get all the information from the BAS. So here we're going to go to the front end of the BAS, and then we're going to connect that to like an analytic engine in another computer. And we're going to feed it all the BAS data, and then this other computer is going to run the analytics, as an example. Good question.
Good question. How about, I did this one, but any questions on this one? Does this look pretty familiar to everybody?
What are we doing here? Centralized control console?
Yeah. You pull it, this is the nightmare is over.
Okay, yeah, this
And
is
you
the
kind of
goal.
have everything sort of tidied up.
Yeah, this is the goal. So some people refer to this as single pane of glass type of thing, where what you're doing is you're bringing all the information back to We used to say a single like pane of glass, but reality, we're bringing it back to a single platform, a software platform. And once we have it in that platform, we can share it with the owner however they need it, whether it's visualization through a web page, whether it's a text to their phone, whether it's I could go, there's 100 different ways to share information now. It could be back on a panel in the place. And that's the ideal condition today when people try to put together a BAS.
Yeah. So physically, that's kind of what it looks like. The guy, it was actually the guy in the same shirt looking at those two things. But what does it mean at the level of, how did we make that happen? How did we make that tidy controls panel happen with the beautiful central console? And it was that you had an engine in the middle, which is often known as a building automation system, but that does data normalization, integration, and normalization. So the way sometimes these are called the bow tie diagram or the bug. My favorite one is it's bug with wings, that you have that central data repository, and you're taking in data from these various systems. Now, in this audience, as BACnet, as Scott's already pointed out, here in the heating and ventilation world, BACnet's the most important standard. And yes, building automation systems, very good at HVAC kind of data, and we're very familiar of running metering kind of data because it's so connected, and when you're providing comfort and energy efficiency, to run that through your building automation system. But when you get to and lighting, as I said, I was at the BACnet lighting. You can actually, and you also have Dolly and LoRaWAN for bringing in that kind of data. Point to the ceiling and the 6 zones. That your number of points of control expands hyperbolically when you start getting into lighting. And so building automation systems also start expanding their capabilities to take on different points and a multitude of points. And so sometimes the building automation system all of a sudden changes name, and it's called a smart system or a smart building automation system or an intelligent. They've got many names for them. But really you can, in that centralized engine, expand it to whatever you need to cover all these different points. Water, bring water data in, because water is especially in healthcare environments, your water data needs to be mixed with your zone data. You want to have working closely with your utility to understand the metadata attached to that would be like how much chlorine's in the water. There's just all sorts of data, different kinds of data that you can centralize in this middle of, and some people call it the independent data layer. You don't have to.
Don't use that word.
You don't have to call it that.
Don't use that word.
You don't need another layer of software, really.
Right. We don't like that in specifications. It confuses the audience.
Yeah, I don't know. Anything you have to add to this picture?
Yeah. So this is really where the BAS industry. This is where we are today. We're no longer controls contractors as an industry. Okay. We have become systems integrators. So those of you who do BAS today, you all know this. You are a systems integrator. Why? Because to Teresa's point, we are not just doing mechanical anymore. We're asked to do a lot more. And then if you do owner direct work and the owner finds out you can talk to that device, well, then they're like, can you talk to that one? Can you talk to that one? And it goes on and on. And what's really cool is now we can bring it together, the data integration, right? We can bring all that data together. And I think of it typically, like a good way to think of it is, imagine taking like all those functions on your left and just putting them on the same schedule, right? For maybe energy efficiency. Buildings aren't occupied all the time. I don't need all these services full 100%, 24/7, 365. I need it 40 hours a week, maybe 60. People go home on the weekend, right? So, I mean, just the ability to turn these things off, folks, I mean, we see as much as 30% energy savings just because they're not using it on the weekends and in the off hours anymore, right? So there's energy to be thought of here. Another thing we can do is maintenance and taking care of the building, right? So instead of people having to go to 4 or 5 different sources to get the information on what's going on in the building, they can efficiently go to one place and it's all in front of them. And again, what's really cool is they can cross-function their maintenance. So they can look at these different disciplines, they can put them on similar schedules, they can monitor them together, and then when they go to work on one, if it's physically located near another, they can work on them all at the same time. So it's, you get a lot of business efficiency by doing this as well. Now for the owner, what they get is a better experience because by us being able to mix all this data and then be able to understand it, we can produce better results is what you see on the left side. And we can start to do things for them that will really improve how they can personally operate the building and make their bosses much happier with better information for things like budgeting, for cost accounting, and much, much more, right? For instance, the healthy buildings, right, of COVID, when all that stuff came up, one of the biggest things we saw was a huge spike in remote monitoring, right? Why? Because people didn't want to go in the building. So this type of situation, it was easy. It was easy because everything was already connected. Everything was in a digitized state. It was in a central software platform. Now we were simply going to cyber securely connect that software platform to a remote connection. And now they could remote command and control this entire stack, right? If that's what they had tied in. Just one example of what a big, so, and it goes on and on, all the benefits of this. And
Yeah, the other classic one would be automated demand response, where you want to look at a whole zone and you get the signal in from the utility and you want to pull back on the lights, dim the lights, and you want to maybe move that air conditioning set point differently when when your utility asks, hey, can you do that, so that we don't have to fire up the dirtiest plant. ADR is also something that big companies, big campuses, the local utilities really appreciate if you've got that kind of control in your campus. And the gray area of this, of course, all that represented by the gray mat behind the wings, if you will, is just drivers, connectors, APIs that are developed often by the community that make sure easily plug and play with certain pieces of equipment that are popular and probably on the floor downstairs. Question?
Have you ever integrated utility meters? Or generally, they all have to be in-house.
so you can always put a meter on a building and connect it to a system. A lot of people I know will actually work with their utilities, and a lot of the utilities now have services that you can subscribe to get your utility data real time from them directly. The benefit of those services is, of course, that's what they bill from. So whether you're using it or not, it does, you can use it for some of the cost cycle analysis and things like that.
Clients hold it into the BAS through an API? Or is it
Absolutely, yeah, absolutely. I mean, so the utility integration will not pick up demand, like it doesn't pick up real-time demand. So if you're looking to reduce demand charges, or if you're looking more into the real-time granular data of the energy of the building, you got to put your own meter in. You have to put your own meter in. If you're looking to do billing type work, or you're looking at the rates and stuff, again, the utility has that info for you.
You can also use a pulse output from the meter, which is the technical term.
Well, and they communicate too. Modbus.
Yes.
Yeah.
Yes.
Yep.
Boom. And we've been working up to this, Scott and I, that our industry is changing. That simple case that I showed you in the single building, that for clients, customers of specifying engineers and controls contractors have whole portfolios of and different types of buildings. There's that they want to pull into, for example, their that central platform for energy management or for working with their utility. You know, those big cases that we've already talked about. They want more longer histories of their trends. They want to run analytics against it. The whole industry, now that we've sort of proved we can do something, they want us to do so much more, which causes the need for a different way of looking at your data. Title is architecture. Like when you're architecting it, what are you going to do on premises? What are you going to do in the cloud? And what are you going to do with edge type control systems? Boom.
Yeah, I agree with Therese. And to point out, one of the biggest transformations we're seeing is the adoption of the web. And you'll hear it referred to as the cloud. You'll hear it, remote connecting, whatever, however you want to look at it. But essentially, what's going on is the common functions we do in BAS today are becoming more heavily reliant on an internet connection. And as we increase the internet connections to the systems that we're working on, we increase the cybersecurity risk, and it creates a much different environment than we were in when we were talking about boiler rooms and having desktops sitting on desks. I mean, we had old problems with that. We got new problems with this. But at the same time, we're able now to use things like AI, analytics. We're able to do long-term data storage. We're able to do backups. We're able to do aggregation of campuses. Like you got like a K through 12, you got like 20 schools in there, and your IT department's not real easy to work with. Well, guess what? We can put every school on a secure connection up to a cloud and give you a single interface to it all without even touching your IT network, right, of your school. So what it gives, this new architecture and these internet connections, what it's doing for us is it's given us so many more options to fix the problems we're running into for our customers. And the secret isn't to be scared of it. The secret is to leverage it to fix the problems you're running into. And also with the internet, we get to use the entire IT universe is at our disposal now too. So we can bring that in to help us fix issues as we bump into them. So it's a bright new future for the industry. Yes, sir.
So with all that in mind and with this graphic, you mentioned earlier not to describe or talk about the IDL. Can you dive into that a little further? Why we would, search or seek for an independent data layer?
Sure. The industry is slow to evolve. And as I just mentioned, this whole like IT influx is coming in, and it may be coming in a little too fast for an MEP to handle. And when we start to add IT terms to MEP specifications, and then we send it out to mechanical contractors, and then these projects don't go well. So typically, we encourage the owner to pick an application they like, right? It is an independent data layer in a way, but it's an application. And then they can find contractors that understand that application, and they can hire the contractor to accomplish a data layer, right? It's the same thing, but when people just use that IDL comment, and this is my personal opinion, I think it just confuses the situation. I mean, they still need to, there is nothing independent about a piece of software. It's written by somebody, it's maintained by somebody. So you buy it from one company or buy it from another, let's just call a spade a spade. That's my point. So about it.
I think the buzzwords are moving much faster than the industry. But I love the little elevator icon down there. If I could, kind of like the ADR, I love the little elevator icon that you might, so back if you were on your right side of the diagram, you might want to trend your data and sample what's typical, every 20 minutes or so how much data do you really want to store? And you still have to ask your question, even if you're moving things up to the cloud, you really have to you know, you don't want to have every point just because there are points. You don't want to use every single point. You really want to think about how much data you're moving around and that sampling rate. But then you might have, you know, it's parking garage. That's why I pointed to the elevator. You might have a parking garage that says, I'd really like to know if somebody's stuck on the elevator, which means I'd like to sample here. I don't want them to be stuck on the elevator for 20 minutes. I want to see that little curve for reading the power. If it's just like a stuck fan, like stuck, I want to go send security to unstuck that envelope. I actually heard of this use case that they wanted to sample at a much tighter rate, which means much more data. You have to decide where you're going to store it and how long you're going to store it. And I just use that.
Well, you bring up a great point, which is like when you're designing your BAS, you have to ask yourself, what are the cloud components or what are these internet components? And how will they affect how I design this project? Some of the functions you would typically do in a building, like tape backups and aggregating long-term data, and some of those functions now, the cloud makes a lot of sense for those functions, and you should consider adding it to your architecture as a tool. Okay, so it's really kind of like I said, to me, it's really just opened up your options as a BAS design in how you want to use this new capability. So
again, this is another way of saying bringing back these familiar terms of BACnet and what still you might be using RS-485 for, Modbus for your meters, however you're bringing in your lighting. That's all coming in, but you might have edge devices that are intelligent devices. You might want to do your visualization at the edge, and you might want to say, oh, instead of having servers in a basement, I want to bring that supervisory control up into the cloud. But something that you don't want to do probably is to start creating another set of nightmares by having multiple, creating those same silos, but creating them with different applications in the cloud. So that's something I think as an industry we have to figure out how to avoid.
Yeah, the one thing you want to start considering is like what I was talking about in your design is what do you leave in the building? And we consider that on-prem. That's the physical stuff that's actually physically in that building is on-prem. And then what is, you can say off-prem or, essentially connected to through the internet connection. Okay, you gotta, so as you start to look at your projects functionally, and then what's at the edge, which are, these are like the I/O devices, folks, like your actuators, temperature sensors, things like that. So what happened to the industry is every one of these layers now can kind of all do the same functions, funny enough. So in other words, like I now sell sensors that have web servers in them, which is typically what you think a cloud is a web server, right? But dang, I got a bunch of, Belimo's got that energy valve. It's got an Ethernet connection. It calls up to a service. They can tell you how much energy you're saving. So that's edge to cloud directly, right? So this becomes a little bit confusing. So you just got to start to ask yourself, okay, so from the standpoint of the owner and their functional goals for the information, with all these options now at hand, how do I best serve them the information? Right? And that becomes the basis of what the option you may choose from that device as a method to use it. So going back to that sensor example, if I have a sensor that has a web server, BACnet IP, BACnet MSTP on it for communications, right? So as the BAS designer, if I already have a BACnet MSTP network running throughout the building and I just need to get the data from the sensor, I don't need it served as a web page, I'm just going to tie it into my BACnet network because it just makes sense. But if I'm in a existing building, it's a retrofit, the sensor's like 200 yards from my nearest network job or my network, my MSTP network. Well, maybe I'm going to use the owner's network and I'm going to pop it on Ethernet. And I don't need that data into my BAS. I just need to feed them gunshot detection. And that's all they want to know, which has nothing to do with BAS, say. So I'm just going to simply put that thing on the network and let its web server do its job right on the network, right? Same device, but now I'm just looking at how I'm going to use the communication differently. And again, every layer has all these new options as we go. So it's a wild, wild west out there for architecture.
Yes, yes. And any questions, by the way, before we, yes?
Yeah.
Can you give examples of the edge device or edge devices you've seen put on Ethernet in the same situation you just described? What kind of?
Yeah, can I go back to the ceiling? You know, like,
I mean, are we talking?
there's a sensor pack, it's got a microprocessor, in.
Or what?
Could be an occupancy sensor.
So right now, I know we do have occupancy sensors, temperature sensors. We have multi-use, like IoT sensors, they call them, where they package like we have one that's like 12 different sensors in one type of thing, right? I know Belimo, the energy valve, has, it also has a network connection to it. Functional device has backnet relays that are, essentially MAC addressable. There's quite a few. There's a bunch on the floor. A lot of the new development in the input-output devices is incorporating that type of smarts into them. Again, to allow for the flexibility and how they get deployed on the jobs. Because flexibility in deployment also lowers the cost of the project, right? The examples I gave you are all to lower the cost of doing, but giving the owner the information. So,
Right. And I'm going to insert here, too, that the building automation system, there is this perception that that's mechanical, that it's just mechanical. People that are at this conference that understand what a building automation system is. If you want some of these other capabilities, edge devices, and for your lights or for your your data center, you have to go to, again, a smarter layer, dependent layer network or whatever, something else. And I think that really we're all working together to make this work so that those edge devices, like certain smarter BAS systems, they have containers that they offer their operating system on containers, or that can be run in the cloud or run at the edge. All that is already happening. So before you start adding extra layers and extra complexity, just look around what's already there and how it's operating in the, it is well outside this industry. Because I think the people working on microgrids as well have their own way, working much, we were at a utility conference. They would say, oh, that building automation system, that's just for HVAC. It really isn't. And we have so many campuses, so many big governmental organizations that have proven this already, but people need to get educated to understand what's going on. A lot of noise in the market. Moving on. Cyber defense. I'm going to let Scott take this one.
So, all right. I'm laughing because Steven is in here. Yeah, Steven, he knows. He knows he's in trouble. He knows he's in trouble. He's the chief architect of the Niagara framework, and I'm always thankful because Niagara's done a great job of continuing to add the features we need to keep securing as much as we can. And but the reality is the industry is very non-secure. Most of the controls manufacturers, I hate to tell you all this, they don't really even have cybersecurity people on their product teams. Crazy enough. And so what's happening with cybersecurity is it's like, those protocols that we were using were serial. They were 485, kind of like telephone wire for communicating the controllers. Well, most of the major manufacturers have now moved that protocol over to a Ethernet or a typical wide area network, type of configuration. And what that does is that puts us in the same line of fire as your home PC that could get hacked, okay, in terms of the cybersecurity environment. And with that, we've essentially created a new environment where just like in your building architecture, you have to consider the cloud and use it. I recommend you always use it in every project, but you have to secure it, okay? You have to secure it. There are different types of attacks out there. Well, first of all, like those stats, I just want to review them with you. 41% of small businesses in the US were a victim of a cyber attack. Okay, I'm the president of Cochrane Supply. I'll admit, we got hit. Christmas Day. They came in through our VPN. Nobody even clicked anything. They came in through a secure VPN after they went through all my personal files, because that's what they do. They find out who the owner or the president, you know, they look for all your personal stuff. They make you naked, and then they shut down your ERP or your accounting system so you can't do business. Then they tell you got to pay them like 150 grand in cyber coin, and we'll turn it back on for you. That was what we call a ransomware attack. I don't know if it's the most common, but it's the one that I hear about the most from other business owners. It seems to be the most common. Globally, 48% of small businesses have experienced a cybersecurity incident in the past year. That would be me. I'm one of the 48%. And 73% know they're getting cyber attacked, okay? So now Cochrane Supply, we sell building automation systems to systems integrators, and we get calls, and these people don't like to admit it because nobody likes to admit that there was a cyber attack around them. It shows incompetence is what people feel like, okay? But the reality is we're getting calls every day now, every week. And typically the call is I'll summarize it like this. Typically what it is that the system, the building automation system, was connected to the internet without consideration for cybersecurity. I'll just kind of put it that as a vague term. A lot of times, the owner's IT department is involved with the contractor in connecting it to the internet. And what happens is the building automation system, if not properly connected to the internet, is actually a beacon on the internet. It's a beacon. It's like going beep, beep, beep. And these hackers, they got these AI robots that are just creeping the internet all day looking for the beacons. Beep, beep. And they catch that beacon, and within a millisecond, they put it on a list, and boom, now a couple thousand hackers know that is an exposed network-connected device, and they know that could be an entry into a bigger network where they could implant some malware and shut the owner down. And yes, they're coming through every day through BAS systems, getting onto networks and shutting owners down in different fashions, okay? This is happening all the time. Nobody's reporting it. Nobody's reporting it, but it's happening all the time. So how do you protect yourself in your BAS architecture from these incidents, okay? And that's a very long, detailed answer, which we had a session on earlier, and it could have gone for another 4 hours, so we're not getting into the technical details. I'll give you 3 key areas to consider on any one of your BAS projects for cybersecurity, okay? The first thing is the connection to the internet. That is always the first thing to look at. And is it protected? Is a VPN the right way? Maybe. They now say no. There's a new methodology called Zero Trust. Zero Trust is a VPN plus. It's kind of like a VPN, but now when you come into the network, it doesn't just let you into the whole network. It only gives you certain paths within the network, restricting your flow, and again, adding safeties along the way. So a Zero Trust network connection is something to consider if you want to remote connect to an owner's building, all right? Second of all, if you're putting your devices on the owner's network directly, like their business IT network, is the communication network encrypted that you're putting on their network? So if it's just BACnet IP that you're putting on like a college network, there's going to be 1,000 kids on that campus that can decode BACnet IP and mess with set points. And BACnet describes where the set points are. So it doesn't, so when you deploy on an owner's network, we need to make sure that, like I said, there's, that you have an encrypted method. Now, right now, BACnet IP is not secure, but they are coming out with BACnet SC, BACnet Secure Connect. A lot of talk about it at the conference. That's going to give us an encryption layer. It's also going to give us certificates.
Certificate handling.
And certificates, what those do is that verifies that that device is set up and working on the network the way it's supposed to in a cyber secure manner. And so that's going to help us even more on that layer. And then the last layer is really authentication. And for the authentication is how you log into these systems. And as a company, whether you're an end user, contractor, even an engineer, it's imperative that you have, policies for the handling of authentication into your network, but more importantly, your customers' networks. So that the authentication rights into your customers' networks, you have a policy to make sure it's not being given away.
Right. Role-based,
So,
multi-factor, all those buzzwords.
so 3 tips for you. Like I said, look at your remote connection, zero trust question. Look at your internal networks. Are they encrypted or not? And then how are you handling authentication? If you focus on those 3 areas, you'll be doing better than most. Any questions about cybersecurity?
Yeah.
Did I scare you enough? Anybody not scared? I've been living through it, so I'm scared. Yes, sir.
So, how often as designers, integrators, et cetera, are you looking at, let's not go on the owner's network, let's create our own BACnet network that gives you more airspace?
Yeah, it's a great question. The question was about how often are people deciding not to use the owner's network and put in their own IT network in order to connect all the devices? The answer to that is more and more. As the manufacturers have adopted IP-based devices, many contractors now find it easier to put in their own networks. First of all, a lot of the devices that they connect to, they were going to connect to anyways. So they already have the money in to run the wire. So that, people say, oh, it's more expensive. It's not really that much more expensive because they were already planning on doing this. And then the other thing too is like when you're in the phases working with the owner on a project and you have to negotiate with the owner's IT department to put your controllers on it. How many of you are contractors here? Any of you have to meet with an IT department about putting some controls on their network? Yeah, how many hours did that add to your project? And that counts, right? Those hours of negotiating with an IT department, or even worse, having to change your protocol strategies to meet their requirements, or you have to add a bunch of cybersecurity stuff on top of your system to meet their requirements. So it's very complicated when you go onto the owner's networks. The other problem with the owner's networks, and another reason to run your own, is because you're now liable for anything that comes in on their network that you can't control that blows up your system. So now you're adding the liability of an entity that you have no control over that will dictate whether your system may be or may not be successful. The network that we're talking about here, the one that you put in for the BAS system, we call it an OT network, Operational Technology Network. That term started in the industrials who moved over to IP-based control maybe starting in like the 80s. So it's been around for a while. It's not a new term. But what it refers to is think of an IT network as the business network in the building. The OT network is there just for the building, not for the business that's going on inside of it. It's funny because one other point to that, a lot of buildings too, the owner comes in and then the BAS goes on the owner's network and then the owner moves out. And then the whole IT team of the owner moves out with it, and now there's no network for the BAS to stand on because the IT department's gone, and so is all their gear, right? So that's another reason for an OT network is because the building may have different occupants in it with different IT networks for their own businesses. That's separate from running the building. So, great question.
Great question. Yeah. So I was just this idea of, I showed you today, the state today, and kind of where we're going in the near future. And then this is another buzzword, flat architecture. Why are you doing any of this? I've talked us through all these protocols, all these open protocols. It's like, no, we're from IT, and I think you should just have a flat architecture. Everything should be IP, and just stop using those legacy protocols like BACnet, and it's going to be great. And I would say we're pretty far from that. I can see the beauty of that. But today, and it was only reinforced in Phil's Zito's earlier, because he got the same question, why isn't it just all IP? Higher cost of IP controllers, the non-reliability is something that Phil brought up. Higher cost of Ethernet cabling, you have to fight for that from the beginning. And then if nobody uses that data, so you better have some data scientists on board, because if you're going to collect and store, it's always going to cost you something to put a lot of data in the cloud. And if nobody uses the data, there's going to be no ROI. So why aren't we there yet? Well, it's costly still. We don't have the skills and the training to go from to this level today. And in a way, this is a very old term, but they used to call it security by obscurity. We're certainly not in that world anymore, but it makes a huge threat landscape to say we're just going to use one protocol. So anyway, you might have some thoughts on that.
Yeah, so currently, the current common BAS specification calls for BACnet MSTP as the communication protocol. It's pretty standard. I would say 70% of the specifications I run into have it. And MSTP is a daisy chain, and it would come back to like a front end or a global controller that then would have Ethernet that you'd connect to a network, right? So when we talk about the flat architecture, we're talking about getting, instead of that MXTP and having that gateway type product, now we put all the controllers right on IP. And then we get rid of the gateway because we don't need it. Because we have software running on that network that will help all those devices to work together. And that's why it's flat, right? Before we were going like sensors, controller, master controller, internet. What we're doing now is we're just putting the controllers on a network and connecting it to the internet. There's no tier below or above. The sensors are becoming IP, the controllers are becoming IP, and we can run a platform on a network, like off of a server, one server somewhere, okay? And so Cochrane Supply, we have sample designs of this on a website. It's called smartbuildingdesign.com, smartbuildingdesign.com, and we have free architectural drawings of what this looks like in reality. So what you have is you have an IT network, or what we call an OT network, with switches, and then you have devices that come back to the switch, and then the switches are connected to each other, like on a riser type of an example. So imagine like a 10-story building, you put a switch on every level, you'd run a riser, maybe a fiber optic backbone to all the switches, and then you'd run Ethernet to each device from the switch in the space. A lot of the HVAC Ethernet-based controllers have 2 Ethernet ports in them, so you can daisy chain them. So you don't have to home run every Ethernet cable back to a switch, okay? And this real quick. And so this flat architecture, what it does is the advantage is that it reduces costs, it reduces complexity, and it, most importantly now, it gives you an environment where you can do cybersecurity, you can do software updates, you can aggregate all the data from all the devices. You can bring other software in to help, like analytics and other things. So it opens you up to use, it kind of future-proofs your BAS, if you may, for what's coming. Because we're going to keep getting better tools, like AI tools, better, on-prem tools, like stuff we can run in. And if you have this type of architecture, and let's say somebody comes out with a better VAV controller that you like better, dude, plug and play, man. Click, install it, click, bring it into the network, boom, you're done. So it gives you sort of that, like almost like unlimited flexibility in the devices that you choose to use and how you choose to use them when you go to the flat architecture. So the advantages are just enormous. The industry is slow to adopt, so it's only at about 20% of the jobs, new greenfield jobs we see are like that today. But it was probably only 2 or 3% the year prior, and I imagine if we're here next year, it'll probably be half, maybe more.
Yep. I always think about, networks are flattening all the time. It's one of those Moore's laws, Metcalfe's laws. I'm sure there's a name for it. But when the car analogy would be like charging stations. Tesla was the first one to come out with charging stations that they were trying to proliferate around the country. It just doesn't make sense if you're really trying to grow the whole market. To have every different, you can only pull up in a Tesla to a Tesla battery, or for charging. It makes so much more sense if they really want the whole market to grow. Is that those silos have to be flattened, and I think we did the same thing with the Jace. We had all these silos, which harkens back to my first picture of different brands. Different servers, everything, we've got to sort of converge to a standard. So I have no doubt that eventually we will converge to more and different standards, and some of these legacy protocols will go away. I just think it's going to take some time.
Yeah. Well, but the advantages are clear, and more people are seeing the advantages. And as more and more IT departments get involved in our business, we're going to see that the demand from the owners is going to push us in that direction as well. And so, like I said, I think we'll see it in the next, at least in probably, like I would imagine next year, 50% of the projects will be 100% IP. The greenfield stuff would be my guess. And after that, it's just going to keep going. And as we know, what do the manufacturers like to do with their older products? Discontinue them. Make you buy new ones. And all the new ones have IP. So by nature of that, we're going that direction too. No matter what. Can't stop it. So just keep that in mind. There's just no stopping this train. Yes?
Your greenfield clients who are doing this, flat architecture, are they also setting up a separate OT network, isolated from the building?
They are. And there's a way to specify it. For greenfield in terms of moving it out of the typical mechanical control spec, separating, putting into a systems integration spec, calling out the other divisions that will be tied into that network, identifying what gear needs to go in on that network, cybersecurity policies. It's the Division 25 in the new CSI numbering scheme. 250-100 is the one that lays out the platform. Be a good one to look up. And again, we have examples of those specifications up on smartbuildingdesign.com. We have different platforms up there that you can pull those specs down. There's systems integration specifications that talk about it. Any other questions? Yes.
I have a follow-up question to the OT network. So with that, would I have to maintain my own ISP connection, or would I be able to connect to the internet with the owner?
Yeah, that's a good question. The question is, with an OT network, do you, the OT provider, have to connect it to the internet, or is that something the owner does? And I think the answer is really it's job specific. What I recommend is, obviously when you're running a network inside of a building that has a network, it should be coordinated with the current network providers. And through that coordination, there should be a conversation about how your network is going to be remote connected to, because it may have an impact on theirs. And so it's really back to collaboration with the owner on the remote connection. But even though you need to go to them, don't go to them with like, hey, can you help me remote connect this? Because that's a mistake. When you go to them, you want to have a solution in mind, maybe even propose it to them, and then let them tell you, well, that's nice, but no, we prefer you do this, right? Because you definitely want to go in there with a way of doing it, because a lot of times now, there are a lot of owners that really don't know what to do with you. No offense, but they're just like, dude, you're with the maintenance guy? Like, I don't know. Do whatever you want. Yeah, okay, thank you. We have a plan, you know? And remember, though, you're liable. But you're liable whether you go through their network or you provide your own. So just, you know what I mean? So it's sort of like, but that's why you want to do the best job possible of cyber securing it yourself. Take that full responsibility, and you'll mitigate your liability. Good question. Any other questions? What? We got one in the back? Yeah.
I'm just curious to hear your thoughts on adding wireless to the flat network, because that would be true cost savings, right? Like, and complexity savings, because wireless networks are getting resilient, meshing, and it's not a lot of data that you're talking about compared to main.
Yeah, the question is OT networks and wireless? Do you want to say something, or want me to jump on?
Go for it.
Okay, so the OT networks with wireless, so Wi-Fi is a network. It's no different than it is physically different, but from a connection standpoint and kind of like the way it the data that can move, a Wi-Fi device can be utilized in a network configuration, right? So with the flat architecture, you open up the use of Wi-Fi cautiously. Again, cybersecurity, other people, stuff cautiously. And then there's other new technology that we're using now, LoRaWAN, which Therese mentioned. It's an interesting technology this is another type of Wi-Fi, but it's a low frequency. And what low frequency gives us is distance. So we can put like a LoRaWAN radio on a network, and we can pick up sensors 2 miles away. And a lot of the sensors now have their own power generation, whether they be solar or they be vibration based. And so, you can go and put a vibration sensor on a pump on the other side of the, campus and pick it up now, right? With just, with that wireless connection, and just by putting a LoRaWAN radio on your OT network. So to your point, wireless can really drop the costs. It can allow you to pick up data where you couldn't before, increase the amount of data you're picking up, and there's just so many more options now with the flat architecture. Okay, I think we're out of time. So
We did it.
well, thank you all for being here today, and I hope you all got some good nuggets. Thank you.